Welcome everyone to this quick crash course overview lecture on NumPy, which is a numerical Python library, and we're essentially just going to show you the very basics of it and how we're going to use it in this course. Let's open up a Jupyter Notebook and get started. Alright, so here I am with a new Jupyter Notebook, and the first thing I'm going to do is import NumPy as NP. And let's go over a couple ways that we can create arrays. So we're already familiar with a Python list, 1, 2, 3. Which is elements in a sequence, and if I want to convert this into a NumPy array, then I can say np dot, and if you hit tab here, you'll notice that there's a ton of functions that are built into NumPy. The majority of these we will never use, but we may be using array, so you can cast or really transform a list into an array. So if you run that, you can see now it's an array, and if you check the type of this object, it's no longer just a list, but instead it's a NumPy nd array, meaning n-dimensional array. Okay, so then we could also save this or assign it to a variable and then call back that variable later on. And again, remember, it's just Shift-Enter to run a cell. Now, that's the way you can cast a list into an array, but lots of times we'll be using a lot of built-in functions with NumPy to create large arrays very quickly. So one way to do that is by using the arrange function that's built into NumPy. Again, just clicking tab there to autocomplete. And arrange, the way it works, if you do shift tab here, it'll basically tell you it's essentially NumPy's version of Python's normal range function, where you indicate a start, a stop, and then as an option, a step size. For example, I can say start at 0. Whoops, let me make sure I click on that. Start at 0, go up to, but not including 10. And then I'll see 0 through 9 here. So you can see that we have 10 elements in an array, evenly spaced by 1. Don't be confused by the fact that it doesn't go all the way to 10. It's because it's going up to, but not including that last stopping. So if you actually wanted this to be 0 through 10, you would then have to put in 11 here, and then you would get back 0 through 10, which would be 11 elements. Now, if you actually want to indicate a step size, for instance, you want all the even numbers, as a third argument, you can indicate, hey, go in steps of 2. And then when you run this, you can see you have 0, 2, 4, 6, 8, 10, etc. So that's a range, again, a start, stop, and step size, very similar to Python's built-in range function. Now NumPy also has lots of useful tools for quickly creating specific arrays, such as an array of zeros. So zeros can either just take in one digit or one integer, and it'll return back a one-dimensional array. You can see here it returned back 5 zeros. Or instead, you can pass in a tuple of dimensions. Maybe you want a 3 by 5 array or matrix, a two-dimensional array. And when you run that, you can see here I have 3 rows and then 5 columns of zeros. So that's the way NP zeros works. Essentially returns back an n-dimensional array, depending on what you pass in, the dimensions of that, where they're all zeros. And note that it has a decimal point here indicating that these are actually all floating points versus integers that we had over in a range. And a lot of times with the operations we perform with TensorFlow and Python, NumPy is going to be transforming things to floats to make sure that we don't accidentally lose information. Okay, so now let's go ahead and discuss a couple more ways of creating arrays. There's also a similar ones function, same deal here. If you pass in a single integer, it's going to bring back an array of ones. Note again that they're floating point numbers. And then we can do something like a 3 by 5, and let me pass that in as a tuple, although I believe it doesn't matter either way. Here we go, 3 by 5, 3 ones by 5 ones, and there's ways of creating linearly spaced arrays. So there's linspace, and basically linspace works by you providing a starting point, a stopping point, and then the number of elements you want evenly spaced or linearly spaced between the start and the stop. For example, if I want to start at 0 and go to 11, and I want 10 points there that are evenly spaced, it's going to return back this right here. If I want 11 points that are evenly spaced, then I can see it's jumping up in steps of 1.1, then 2.2, 3.3, etc. If I want 100 points between 0 and 11 that are evenly spaced, then it goes 0 all the way to 11. So note the difference here between linearly spaced and arrange. Arrange takes in a start and stop, and then you actually define what jump or what step size you want to take as you go along. Linearly spaced, or linspace instead, again, start, stop, but then you say how many points do you want evenly spaced between that. So you could ask for just 5 points evenly spaced between that, or you could ask for 5,000 points evenly spaced between that. And note here, if you ask for a super large array back in Jupyter, it just indicates a ... All right, so that's lin-spaced, very useful to know. Let's go ahead and cover random NumPy arrays. A lot of times when we're dealing with neural networks, we have to initialize things with random values. So NumPy is a really nice random library. You can say np.random and then hit tab here, and there's lots and lots of functions that are included in this random library. We won't be using all of them, but we'll introduce a few of the common ones. One of the common ones is ranInt, which, as you may have guessed, returns back a random integer. So we do shift tab here. You basically give it a low number and a high number, and then you can also indicate a size, so the dimensions you want. And note that the low number is inclusive and the high number is exclusive. So let's show an example of that. Let's say I just want one random number between 0 and 10, where 0 is inclusive, 10 is exclusive. You run that and you get back 6. If I run this again, I get back 0, run this again, 8. So every time I run this, I'm going to get back a different random number every time. And sometimes it gets repeated. So there we got 3 zeros in a row. If we make this larger, we won't see as many repeated values because the likelihoods are 1 in 1,000 here. Okay, so just random integers, that's how it works. And if you want dimensions there, I want 3 by 3, 2-dimensional array or a matrix of random integers. I can run that, and there they are. So run this again, another set of random integers. Now there's other random ones that we're going to be using, things like random normal is another common one. So you can give a location, a scale, it just draws random samples from a normal or Gaussian distribution. There's lots of random distributions that you can choose, so keep that in mind. We'll introduce those throughout the course as we encounter them. So to finish off our discussion of NumPy's random module, I want to talk about setting a random seed. And that's going to be important to make sure that the random numbers I generate are the same as the random numbers you generate. So in a cell, go ahead and type np.random seed. And then you can seed the generator of the random numbers. And typically, I use the value 101. May change it up. But what's important here is now, if I say np random.ranInt, let's say 0, 1000, give me 10 random numbers, run this, I get back, starting from 95, a bunch of random numbers, and ends in 40. However, note, if I were to run this again, I constantly get back the same random numbers, and that's because I've set this random seed. The important thing to note here is that this random seed is currently in the same cell as this random integer command. And that's important because if I were to copy and paste this into another cell, I won't get back the same random integers because that's the second time I run this. So if I want to make sure that I constantly get back the same random integers, I want to make sure that I'm resetting that seed every time. So again, make sure that that seed is in the same cell as whatever operation is generating random numbers to make sure that you're actually taking into account that seed. Because if I keep running it outside of this, then even though I've set that seed, it's going to keep generating as I ask for them. I have to reset the seed in order to get back that same sequence of random numbers. Okay, that's basically all we need to know about creating NumPy arrays, either one-dimensional or two-dimensional. Later on we'll learn about tensors, which are essentially three-dimensional or n-dimensional arrays. What we're going to do now is quickly cover a few useful operations. So if I have an array here, let's go ahead and generate run. We'll say random ranInt 0, 100, 10, and let's go ahead and grab that seed just to make sure that we get the same numbers here. So I've asked for this array. You should have the same numbers I do. If you want to find the max value of an array, you can just say max, call it like that. If you want to find the minimum, you can just call minimum. There's lots of other functions and methods you can call here. If you hit tab, you can see a bunch of them here. We definitely won't be using all of these. A lot of this is happening in the background with TensorFlow, but you can do things like also grab the average. What's also really nice is that if you want to grab the index location of the max value, so the max value here is 95, but let's say this is a huge array and I want to know where is the actual index location of that max value, I can use argmax, and that returns back 0, which is the index location of that max value. And there's the same operation for argmin, where it's going to return the index position of the minimum value. And very quickly, to end our discussion of NumPy operations, I want to discuss the reshape method of an array. So if I take a look at my array right now, it's one-dimensional, it's just 10 elements. But I can actually reshape this using the reshape command. And here I can reshape it into whatever shape I want, as long as the 10 elements fit out evenly. For example, I can reshape this into a 2x5 array. And here now I have the 2 rows with 5 columns. And we'll be using reshape to reshape tensors a lot. So again, reshape, very useful. It just reshapes an array. Finally, let's go ahead and discuss indexing. So I'm going to create a matrix. We'll say NumPy range 0 to 100. And then I'm going to call reshape off of this to be a 10 by 10. And this sort of stacked methods on a NumPy array is really common. So now I have a nice NumPy array, 0 through 99. Remember, it goes up to but not including 100, and it's 10 by 10. So it includes a little 0 there. So the way I can grab stuff, if I just want to grab a single element, let's say I wanted to grab the value at the, let's say, first row, second column, what I could do is say mat, or whatever the name of your two-dimensional array is, and then you pass in the row you want, starting at index 0, and then you can pass in the column you want. So in this case, I want column 1, and this should return the value 1. So let's go ahead and practice. Go ahead and choose a random number here. I'm going to choose 43. So let's try to index out 43. That's at 0, 1, 2, 3, 4. So it's in the 4th row. And then column-wise, 43 is at 0, 1, 2, 3. So let's go ahead and put in 3 here. Run this, and there I have 43. So again, it's just the index location by row, comma, index location by column. So that is how you can get a single element out of a two-dimensional array. You can also use slicing to grab chunks of this array. And it works just like regular Python slicing. So let's go ahead and say mat. Let's say I want all the rows in the first column. So that is, I want all these rows, 0, 10, 20, 30, but just for the first column. So essentially I just want 0, 10, 20, 30, 40, etc. What I would do is I would use colon to indicate everything as far as rows is concerned, and then I can pass in 0 to indicate that I only want that first column at index 0. Run that, and now I can see I have an array here, 0, 10, 20, 30, etc. I can also do kind of the opposite effect. So grab all the columns in a particular row. So if I just wanted to essentially return back a single row, I could say 5, comma, colon, and it returns back that entire row. A little weird because you kind of have to think about it backwards. The fact that you're selecting all columns for one row returns back the whole row, but that's the way it works. Again, it's row, comma, column, and you can use colon to indicate everything. Then you can also do slices. So let's take a look at our matrix again, 0 through 99. And then what we're going to do is say mat here. And let's go ahead and grab just this first chunk, 0, 1, 2, 10, 11, 12, 20, 21, 22. What I'm going to do here then is first slice off my rows. So the rows I want is 0, 10, 20. So that is starting at index 0 up to, but not including, 3. So that's 0, 1, 2. Again, I'm going up to, but not including that third index, or really that 4th row at index 3. And then we're going to do essentially the same thing for 0, 1, 2. So I'm starting at column 0, then slicing all the way, but not including that index 3 there. And that should return back 0, 1, 2, 10, 11, 12, 20, 21, 22. So if this is confusing to you, go ahead and practice a little bit. So see if you can select kind of random chunks from this array and go ahead and index them. The most confusing part, I believe, for beginners is the fact that it goes up to, but not including that last slice index. Finally, let's go ahead and discuss masking. So masking is a super useful attribute of NumPy. So I want to show it off. Basically, if you have a matrix here, you can perform a Boolean operation on it. For example, I could ask, hey, where is this matrix greater than 50? And it will return back a matrix of Boolean values. You can see they all start as false, and then once it becomes greater than 50, they all start returning true. If I actually wanted to only select those values, I don't want just this 2D matrix of Boolean values, but instead I want the actual values. What we can end up doing is the following. We can say something like, my filter is equal to this, and then I'll grab my matrix again and pass in that filter. and then it returns back all the values that happen to be greater than 50, and there they are. Typically, you don't see this done in 2 steps though. Instead, what you end up seeing is something like mat, and then inside of that, mat greater than 50. And this is known as Boolean masking or just masking in general. It's super useful, and we'll be seeing it a little bit throughout this course. Okay, that's really all there is to it. You can go ahead and review the notebook in case you want any of the code I ran here. Thanks everyone, and I'll see you at the next lecture where we'll quickly do a crash course for pandas, which is built directly off of NumPy.